Hello friends, welcome to the Engineering Funda family. In this video, I'm going to solve 4 very interesting examples based on fragmentation and IPV4 frame. In my previous video, I have already explained how fragmentation and IPV4 frame is there. For that, you just need to go through my last 2 videos of computer network lecture series. In that, I have explained how fragmentation and IPV4 frame is there in great details. Right. In this video, I'll be solving 4 interesting examples. You can observe all those examples and you can freeze the video and you can try the solution by your own, and later you can check for the answer in my video. Here I'm going to solve all those questions. If you don't have an idea, then definitely you will be having idea after watching this video, right? So let us solve these questions one by one. So in first question, consider an IP packet with a length of 4500 bytes that includes 20 byte of IPv4 header. So here we are given with IP packet. Let me note it down. We are given with IP packet, and that is having how much size? 4500 byte. And out of this, 20 byte of IPv4 header is there. So you can say 20 byte of header is there and plus data will be there. So 4500 minus 20, that will be 4480 byte. So here we have 20 byte of header and here we have 4480 data, right? And 40 byte TCP header. Students, here 40 byte TCP header, that won't matter with IPv4. Why? The reason is 40 byte of TCP header that comes into the transport layer, right? So here IPv4 is functioning at network layer, so you don't need to worry about 40 byte. This is extra data that is given to us. The packet is forwarded to IPv4 router that supports a maximum transmission unit of 600 byte. So here we are having MTU, maximum transmission unit, that is of 600 byte. Assume that the length of IP header in all the outgoing fragments of this packet is 20 bytes. So here we are having fragmentation, and with all the MTUs, header size is 20 byte, that is given. So you can say, see, 600 byte, that is having 20 byte of header, and 600 minus 20, that will be 580. So 580 byte. But here remember one thing, see, this 580, that must be divisible by 8. If it is not divisible by 8, then you'll have to reduce the number. So let me check. 580 divided by 8, so that is 72.5. So this is not divisible by 8, so you will have to reduce that to 576 now. So now let us make it to 576. Now see, 576 divided by 8, that is 72, means it is divisible by 8. So this data of MTU, see, this is header of MTU and this is data of MTU. So one condition that you will have to remember, see, this data, it must be divisible by 8, right? This is the condition that you should know. Now see, what is the question? Assume that fragmentation offset value stored in first fragment is 0. So first fragment is having offset 0. The fragmentation offset value stored in third fragment is how much? So here I'll solve so many questions. Not only this, let me explain you first how fragmentation happens, right? So here what I'll be doing is, I'll be noting fragment number. So let us say this is fragment number 1, this is fragment number 2, this is fragment number 3. And along with that, here I'll be storing offset and here there will be data, right? Now let us see how things are happening. So see, first fragment, that is having offset 0. And how much data that we can transmit over here with MTU? 576. So here let us write 576, right? So 576 data that we are storing. Now see, when you have second fragment, at that time there will be offset because of this data, right? This is 0 means what? Here we are starting from first 0th byte. Now see, this is 576, right? So 0 to 575, that data is available in fragment 1. So next data available over here, that will start from 576. So 576 divided by 8, that will be offset over here, right? So 576 divided by 8, that is 72. So 72, that is offset of fragment 2. And again, you will be sending how much data? 576. Now see, 576 plus 576, that is how data is added. And we need to transmit up to how much data? 4480, right? So third fragment, that will be having how much offset? See, this 72 offset, that will get added again. So it will be 144. And again, you will be sending 576, right? See, this is how fragments will be there. Like if you talk about fourth fragment, then with fourth fragment, 144 plus 72, that will be 216. That will be the offset, and in which you will be sending 576 data, right? That is how we can calculate offset value. So for third fragment, offset will be 144, right? Offset will be 144. Here there can be one more question, like how many fragments are there? How many fragments are there? So you can say number of fragments, right? That will be how much? Number of fragments, that will be total data, that is 4480 divided by size of data in MTU, that is 576, right? So 4480 divided by 576, so that is 7.77. But see, if anything is greater than 7, that will be 8, right? You cannot send 0.77 fragment. You will have to send complete fragment, right? So here you can say 8 fragment that we will have to forward over here, right? There can be question like what will be offset for sixth fragment. So in sixth fragment, how to find offset? See, with each fragment you will be adding 72 offset. So with sixth fragment, 72 into 5, that will be the offset, right? So that is how directly you can solve questions. Let us have second question over here. So in second question, see, the maximum number of IPv4 router addresses that can be listed in the record route RR option field of IPv4 header is. So in my video of IPv4, I have explained that, right? If you have seen that, see, record routing, right? Route recording that is happening. And in that, what we were been storing? We were been storing IP of routers, right? So it says like by which path frame is getting forwarded. So I have told you, like with option field, maximum data is 40 bytes. Out of 40, 2 bytes are reserved. So available bytes are 38. So with 38 bytes, how many IPs that we can store? 9 IPs that we can store. So for route recording, maximum 9 IPs that we can store, right? So over here, you should know, see, we are having option field, with maximum data, how much? 40 bytes. Out of 40 bytes, 38 bytes that is available, but 2 bytes that is reserved. This is reserved, right? That cannot be used for route recording. So by this much number, how many IPs that we can store? By this we can store 9 IPs, right? So this is your answer, 9 IPs that we can store over here, right? Now let us have third question. So in third question, you see, an IP datagram of size 1000 bytes arrive at a router. So here we are having IP packet, right? IP packet that is having how much size? 1000 byte. The router has to forward this packet on a link whose MTU is 100 byte. So here MTU, that is 100 byte, right? And let me take this bit lower. MTU is 100 byte. assume that the size of IP header is 20 byte. So as if 20 byte size of header IP header is there, then obviously with IP packet also hits this header will be there. So 20 byte of header and subtract 20, so that will be 980 byte, right? So this is what for header, this is what for data which is there with IP packet. Similarly with MTU, 20 byte of header will be there plus 80 byte of data will be there. But see, 80 should be divisible by 8, right? I have told you that. So obviously 80 is divisible by 8. So here you can say this is header and this is data for MTU. The number of fragments that the IP datagram will be divided into for transmission is, so here how many fragments will be there? Question is how many fragments are there? So number of fragments over here, that will be, see, size of data in IP packet, that is 980 divided by data in MTU, that is 80. So if you do this, 980 divided by 80, so that is 12.25, that is 12.25. So anything greater than 12, that will be 13 over here, right? So 13 fragments will be there. So that is how simply we can solve. But remember, you will have to consider header, and in MTU data must be divisible by 8, right? That is the condition. Now let us have fourth question. See, in fourth question, which one of the following fields of IP header is not modified by typical IP router? So here, which following field of IP header is not modified by IP router? So obviously checksum is modified. Why checksum is modified? The reason is after every route, some fields will change inside that header, and because of that router will modify checksum, right? I have explained that. See, source address cannot be modified, right? Source address cannot be modified by IP router. Source address cannot be modified by IP router. See, time to live field, that will change after every route. Time to live TTL field, that will decrement by 1 after every route. So that will also change. And length, see, length will change. Why length will change? The reason is after fragmentation, length of frame will change. After fragmentation, length of frame will change. Like MTU will say like what will be the length of frame, right? Like if you observe here questions, even I have explained, like initially IP packet that was having length of 1000 byte, but because of MTU is 100, now you'll have to fragment it into 100, right? So here instead of 1000 byte of one packet, now we'll be forwarding 13 fragments, right? So that is how it is changing. So here, see, question is not modified by typical IP. So this is our correct option. This is our correct option, right? So now I think you are having fair enough idea about how we can solve the questions and how to approach the question. See, major thing is how to approach the question, right? And probably I think I have conveyed correct message to you. Still, if anything that is required over here, please note it down in comment section. Thank you so much for watching this video.